Well, hello everybody. Just like you saw on lesson 0, when I was telling you a little bit about algebra and astronomical units, I decided to put my lectures from like a long time ago, but they're still good. The lectures are still good. The same kind of concepts apply now, but I decided to put these lectures so if somebody can use it or is curious about astronomy, that they can learn a little bit about basic astronomy. So here we go. This is a lecture that is titled Here and Now, the Scale of Cosmos. And I did this lecture when I was an instructor at Pasco Hernando Community College, West Campus in fall of 2013, long time ago. So I hope you enjoy it. Let's learn a little bit about astronomy. So on our first lesson during astronomy for undergraduates, we're learning where are we in the universe. We kind of covered that on lecture 0. How does human history fit on the time scale of the universe, and how you should study astronomy. So the Earth is obviously our home, is our home planet, and Earth is what is called a terrestrial planet. We will see later there are different kinds of planets, and ours, Earth, belongs to something called a terrestrial planet. We normally use the Earth as a guide to compare with other planets and worlds. Why? Because that's what we know. So we use it to compare with other worlds, other planets, to see if we find similarities or dissimilarities with other planets. In lecture 0, you probably know or heard some of the, when I was explaining to you where we are located, what is our cosmic address. And you can see here that we have the Earth. The Earth, of course, is in our solar system. The solar system is inside the Milky Way galaxy. And the Milky Way galaxy is inside of something called the local group, which is pretty much a cluster of local galaxies. And then, of course, we're inside of something called the local supercluster. Cluster means an aggregation of all kinds of things. It could be galaxies, stars, different kinds of, meteor, comets, all kinds of different things. And then, of course, is the universe. As you can see inside this box, we are talking about the observable universe that we have either been able to observe with our telescopes, directly or indirectly using X-ray or other techniques like gravitational lensing and other techniques. Now, where are we? We know that space and time are critical in astronomy, and you probably recognize this guy here with the crazy hair. His name is Einstein. And he came out with what is called the special theory of relativity. He actually came out with several things, but most people know him from the formula E = mc squared. Now, large distances are very difficult to visualize in astronomy, even mentally. If you try to think of a distance in a space, or a space is really vast, and our mind is not really made up to think of huge amount of numbers or quantities. So to do calculations, as we discussed on chapter 0, we use something called powers of 10 and scientific notation. I'm going to cover again with scientific notation because I think it's important. Scientific notation is a simple way to write a very big or very small numbers. Remember that if we move the decimal point towards the right, then we're making the number bigger. And if we move it towards the left, then we're making the number smaller. As you can see here, we're making the number 6.5 bigger by multiplying it by power of 10 to the 7th exponent, or 10 to the 7th. That means that we're multiplying 10 7 times. So it will be 6.5 times 10 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 and times 10. Oh, thank God it was only 7. But 7 times. The universe is too big to discuss without using scientific notation, and that's why we normally abbreviate everything with this call of a standard of scientific notation. Now this is our neighborhood. Our planet is called the third rock from the sun, just like the show, because we are the third rock from the sun. Count it. 1, 2, 3. There you go. 3. Now a star is a large glowing ball of gas that generates heat and light through nuclear fusion. And you can see this is the sun, and we see some of the hot spots. And we'll talk later on in later lessons. Towards the end of the book, we're going to talk about what is a filament and what are the hot spots and what is their effect on human society and radiation. Now, there are 2 planets, Mars and Uranus. A moderately large object that orbits a star. It shines by reflected light. Planets might be rocky, like Mars, icy, like Saturn, or gaseous in composition, like Uranus. Now, the moon is not a planet. The moon is a satellite. And a satellite is an object that orbits a planet. For example, believe it or not, this is not our moon. This is Ganymede. Ganymede orbits Jupiter. Jupiter has close to 63 satellites. We also have asteroids. What is an asteroid? An asteroid is a relatively small and rocky object that orbits a star. And this is Matilda. And Matilda is a pretty huge carbonaceous asteroid. We also have comets. And normally comets tend to stay towards the end of what we call our solar system, next to the planets that are colder, because let's face it, they're pretty much has a nucleus, which is a tail that has ice and water and gas. And sometimes they have a plasma tail, as you can see. This one has 10 million kilometers. You can see how big the tail is and how it is escaping all the gas through something called a coma. So a comet is a small and icy object that orbits a star. Most comets have predictive orbits that we can calculate, and we know exactly when a comet is going to be around because we know how long it's going to take to orbit around a star. Now, a solar or a star system, and we call it like that because obviously we are in it, a star and all the material that orbits it, including its planets and moon. A nebula is an interstellar cloud of gas and dust. Furthermore, I will tell you this is where stars are born. Stars require several things to grow as babies. They require gravitation, and they require dust and gas to be able to grow. A galaxy is a great island of stars in space, all held together by gravity and orbiting a common center. Our galaxy is the Milky Way. You can see how beautiful this picture is. Now, the Milky Way can be seen, and I apologize for these pictures, but that's it's been a long time I have this PowerPoint. But you can see here, you can see the Milky Way and part of the arm on the Milky Way at night sometimes, when you have very, very clear sky. And what is the universe? So this is the sum total of all matter and energy, that is everything within and between all galaxies. Now this is called WeMap, and WeMap is a representation of all the objects that can be either seen through X-ray or microwave radiation, because anything in the universe makes noise. But it is a noise, obviously. It's not like a boom, or it's nothing that we can hear with the human ear. It has to be only picked up by instrumentation and X-ray, for example, or microwave radiation. So scientists made a map called WeMap, and this is the pictorial representation or graph of all the things that we know on the observable universe. Now there are larger structures, like they're called voids. And void, I think everybody that has played a video game in Roblox knows what a void is. A void is a large structure in the universe with hundreds of megaparsecs in size, containing few and visible galaxies. Pretty much it's like an empty space. It is not empty, but it looks like it's empty. It is obviously filled with what they call dark matter. But most people, that will be something that's empty. It looks like it's empty. A parsec, we already talked about that. And what a parsec is an astronomical unit. And then filament joins clusters and superclusters together. The wall is the vastest structure ever in a collection of superclusters, 1 billion light years away. It extends for 5% of the length of the entire observable universe. And then we have some words that if you're taking astronomy as an undergraduate, you should know, because you're going to be asked about this in your vocabulary. One of them is parallax, which is the apparent change in position of an object due to a change in location of the observer. And this is measured in seconds of arc. And then a second of arc, which is angular measure, 1/60th of a minute of arc. I think we actually covered that on lesson 0. And I wanted to show you, look, this is a beautiful picture. As you can see, the clusters, you can see that gravity tends to put matter together. And so clusters of galaxies and filaments and stars and interstellar gas, so they tend to put together in clusters. And then filaments, look at that. So filaments can be in the interstellar gas. They can be on walls, forming walls like we see below, in which it stands for almost 5% of the observable universe. And then, of course, the voids. Voids are really mysterious. Do they go to another place? Are they empty? We know now that obviously they emit radiation, and also that the energy and the dark matter that's in there has weight. And so it's not empty, but it does look empty. And then we're going to talk about the astronomical unit, which I think that we went over on lesson 0. So the astronomical unit, or AU, is the distance from the Earth to the Sun. You can see that 1 AU, you can see the Sun and the Earth very tiny over there. That's 1 AU. And then the Oort cloud is where a lot of the asteroid belts and a lot of the comets exist in an area. Why do the comets tend to stay on the Oort cloud? It is because it is extremely cold and farther away from the sun. And so that's where a lot of those comets and asteroids are, at 55,000 AU. And then they're just giving you examples of where the planets are located. Pluto, which is sadly, for some people, not considered planet anymore. It was in the 17th called Planet X. And now the Kuiper belt, which is the asteroid belt, is going around. You can see the asteroid belt and then the Kuiper belt, in which there's more asteroids and also more icy comets and things like that. So how often have you measured a distance in terms of time? For example, the doctor's office is 20 minutes away. But you can also say the doctor's office is 2 miles away. You see the difference? So we're going to talk about light year. And this is a mistake that a lot of undergraduates make. Me, myself, I did the same thing when I was an undergraduate. So make sure that you understand that a light year expresses distance and not time. Even though we call it light year, it is a distance. And now finally, we're going to define what is astronomy. Astronomy is more than the study of the stars and planets. It is the study of the universe in which we live. And astronomy, please don't confuse it with astrology, which is different. Astronomy is a science, hardcore science, like mathematics, and astrology is a pseudoscience. Pseudo means fake. But astrology and astronomy have common roots. Most of astronomy, especially when we're talking about stars and calculating distances, and part of mathematics does come from astrology, which is an ancient Hermetic science. Why we observe the universe? Well, if you can see, a lot of the pictures, they're beautiful, right? So we are fascinated by the pictures. We want to know who we are and where we come from. Some people observed the astronomy for a long time, even from primitive man, because we need to know the change of seasons, farming. We understand new phenomena like eclipses, for example, or astronomical cycles, the tides, the movement of the stars, the patterns and motions found in the sky, and of course, because it has a religious and supernatural, we always are asking, why is the universe so vast and so incomprehensible? Our neighborhood, you probably know this already, of course, is comprised of the sun and the moon, which is a satellite, and 8 planets and Pluto. We used to have 9 planets. Now they're saying there might be another planet that is that is very similar to Earth and is also in our neighborhood. Comets, asteroids, and meteors are also in our neighborhood. Thank you so much for this little review on what things are in our universe. I hope you enjoy it. Thank you.